there, my dear Chinese machine learning engineers, how are you doing this whole universe? Hope with this fun nourishment who being swallowed through my own experience. And today we're gonna discuss with you about robust clustering algorithms and application of these algorithms and methods to the biomechanics of athletes that are running, they are doing jumping, they do sprinting, and also ultra marathoning, and triathletes will be here too. A little bit of it and a little bit of that. Let's talk about it. First of all, what's the clustering? Clustering and robust clustering. Robust clustering is sub-area of clustering. And what's clustering? Clustering is the specific algorithm method of grouping objects together. Imagine that we have x-axis and y-axis, Cartesian coordinates, and also we have dots inside of it. And we can connect all the dots that are similar to each other in the specific groups, sets, subsets, multisets, supersets, and things of this nature. We have the specific group, another group, another group. It is actually clusters. One cluster, second, third. And also we have robust clustering algorithms. What's a robust clustering algorithm? You can ask me. It's the question for it's a question of yours, and I have the answers of mine. Actually, robust clustering algorithms, it is the specific algorithms that I imagine that we have again data. We have the specific clusters of data. Here's the cluster 1, here's the cluster 2, here's the cluster 3, and also have some data is here that is not super like clustery thing, and we don't need it. Actually, buhao, it is in Chinese, yes, and we can we actually have this, and this we don't need it. We don't need it actually. Okay, and here's the robust clustering. When we eliminate, delete, remove, and different types of eliminating features that we use to decrease the influence of this thing that is we don't need. Actually, outliers, anomalies, out of distribution data, and deviated data. We don't need it. And actually, we need only this. Why do we use robust clustering? Because we have aggregation functions. Aggregation functions, it is mean, median, or mode that we can calculate from our data, or maybe something else, some of the collection and composition of functions we can use. And actually, I imagine that we have only one set of dots. Here they are, and also we have some dots here, yes, some 3, 4, or 5 dots, and actually we have the main is here, and I mentioned that we have the center of the cluster is here. Okay, everything is fine, and right now we don't have this data. Center we found, but right now we will have this data. The second variant of this, we have again data here, and here's the data too that we don't need actually. And when we can calculate from all the data that we have the center of the cluster, then the center of cluster will be switched a little bit. It will be kind of shifted, and we don't need a shift. We need the correct posture, correct things that we have of this centroid that we have. And actually, it is our rule that we don't need this thing. We need the correct aggregation function that will be nice and good and kind of baik from Indonesian language and kind of these things. Okay, well, I need to do this. Okay, and right now we have the data of things, and we are talking today about biomechanics of athletes, of runners, of jumpers, and etc. And when we imagine that we have these runners and things of that nature, we have biomechanics of their movements. We have the different types of deltoids works, and also of biceps, triceps, quadriceps, soleus, gastrocnemius, biceps femoris, abdominal muscles, and also different types of trapezoid movements. We have different types of movements of our body, of our muscles, and biomechanics of it, and different types of movements of ligaments, and also tendons, and different types of things that we have in our body, joints, yes. And actually, when we talk about biomechanics, we have the specific changes in our space, yes. Pos.x, pos.y, pos.z, vel.x, vel.y, vel.z, ac.x, ac.y, ac.z, which means for us position of x, position of y, position of z, velocity of x, velocity of y, velocity of z, acceleration of x, acceleration of y, and acceleration acceleration of z. Actually, it's interesting that we have this connection and we have the movements of different types of points. I imagine that one muscle, I imagine that this muscle, biceps or tricep, will, or maybe a deltoid, we have the specific dots inside of it and collection of dots, and we have the center of this muscle, for example, or the center of the joint. And I imagine this thing. We do the clustering of this type of. I imagine that we have a lot of dots here. Yes, a lot of super mega lot of kind of 1 million of super precisive, and we have the data, and I imagine that we have a lot of data, and a little bit of switch of it will be the switch in the center of the muscle. I imagine that we have noises, and without deleting, without decreasing influence of this noise, it will be a little bit of switch of biomechanics in terms of the data, in terms of the analysis, in terms of the how computer actually thinks about our data that we put inside of it. Okay, we have these things, and actually it's fine, and then we need robust clustering algorithms, so we can eliminate, delete, remove, and decrease the influence of our outliers, and everything will be fine. How can we do this? We can do this through the Mahalanobis distance, or maybe through the Euclidean square distance, and actually we can use different types of algorithms that mix Mahalanobis distance and Euclidean distance, or squared Euclidean distance. Also, we can use it by different types of isolation forest, or maybe connectivity based outlier detection algorithms, or maybe local outlier factors, or maybe 3 sigma rule, or anything that will detect our, imagine that we have box plot and we have some outliers, we need to detect them. It is the thing, we need to detect them and need then to delete it. Actually, it is 2 steps of doing it, and actually there are more steps, because we need to do clustering, that we need to detect them, then we need to detect outliers, then we need to do deleting or decreasing influence of the outliers, or something of hybrid approaches, and then the last stage is doing the final clustering and seeing that we actually have the correct center, or maybe aggregation function, and value of the aggregation function that we have. Actually, it is what we do, and it is how we apply it. We can apply it to different types of jumping, and in terms of the movements of our body, of our different muscles, again, to soleus, to brachii, different types of, yes, and also to the muscles of it and muscles of that, oblique muscles, and etc. And also to the hamstrings, and to the thighs muscles, yes, and different types of how can we describe it about our body. Okay, and we actually apply it to this, and then everything will be fine. Then we will calculate it nicely, and everything will be in our table in terms of the columns and rows. It will be kind of funny, and we will be happy with our results that we can get from the aggregation functions that we apply to the clustering, to different types of things that we need to calculate. So thank you a lot for watching this video. Hope you enjoyed. Right now you know how to apply robust clustering to this area. Let me know in the comment section below what would you like to see next about robust clustering, different types of applications and algorithms, and maybe things of this nature. And see you next time. So improve daily. You're a nice guy or girl, and you're a nice machine learning engineer. Go forward to learn new things, new approaches, new algorithms, and everything will be fine in your life. And apply it, use it, and work. Everything will be fine. See you next time. Improve daily. Go forward. Bye bye.